Hi, this is Justin Mansell from Active Optical Systems, and this is a quick tutorial on how to use the DATViewer software. When you launch the DATViewer software, you will see a window that looks like this. What you can do is either click the Load DAT file or drag and drop a DAT file onto the screen, and it will load that DAT file. The DAT file viewer allows you to page through the images. In this case, it's 10 images in this. And there's a little tiny spot in the center here moving around. You can page through them using the scroll bar on the left side of the image when you're on the image screen. There's a Histogram tab, but let me jump to settings before I talk about that, because you actually have to activate the histogram and then move the tab around in order to see the histograms coming out. On settings, you can specify a variety of things like the maximum count values. It will tell you how big the images are and how many of them there are. You can flip the images in X and Y, and you can show them as their color frames if you've recorded this from an RGB camera. And so it does the Bayard interpretation for you onto this tab. Since this is not color frames, I won't show you that today. Some of the analysis settings include the ability to set the bucket radius in pixels for power in a bucket calculations and the threshold for those calculations. This button allows you to associate DAT files with the DATViewer in Windows Explorer. You can also create a movie of your DAT files using a decimation factor. In this case, I'm going to set it to 1 so I can show you that in a moment, and set the quality to 100%. And it's going to downsample that to a 240 by 320 image. You also can do a quick calculation if you're interested in trying to specify the bucket radius with this down here that allows you to specify a focal length, an aperture diameter, a wavelength, and the number of pixels per centimeter, and it will calculate for you the diffraction limited spot size and the number of pixels that is. Analysis results and error logs are set up over here, and I'll talk at the end about some bulk processing capability in the DATViewer. So I've already shown you the histogram. Power in a bucket is only enabled after you analyze the images. So I'm going to click Analyze Images. This will take a minute for it to go through this. You can see it's processing down here at the bottom. I'm going to hit pause to, oh, it's done. Good. And now you can see the power in a bucket for each of the frames. It's moving around a little bit as I scroll this around. You can take a look at a plot of the first moment of all the frames and the second moment from all the frames. It looks to me like, given how big this is and how tiny that spot is in the image, that the threshold probably was not set correctly for this image. So I'm going to go in and change this analysis settings to have a threshold of like 20%. And I can hit Analyze Images, and it'll go through and analyze those images for me again. And now my second moment looks much more reasonable. It looks like this was about a couple, 3 pixels kind of size, and that's about what this is reporting. The PIB scan is looking at how much power is in the bucket with respect to frame, given a bucket size specified by this radius. It also goes through and averages images together, both centering and not recentering. So the top left is not recentering and the top right is with recentering. This is an awfully small little spot on here, so you can barely make it out, but it is centered up there. And this looks then at the power in a bucket of the recentered and not recentered images. The recentered quickly gets up, in fact, in 3 pixels to almost full power. The power in a bucket of the sum without the recentering is much lower than that, because we've got a lot of background light and these kind of things that are background light's enhanced, and then the spot moving around is not helping at all. The delta, of course, is the difference between these two. So you can also go back here and click on Use Color Bar, and it will apply that color bar to this image. Of course, I have to advance the scroll bar at the left for this. Sometimes this helps us see these images a little bit better with using a different color bar. You can also specify a minimum count and maximum count for this display. All of the data for this is saved out. In fact, let me pull this over here into a folder. I think the easiest way to show that is just to open up the folder, and I can show you that in that folder, you have the average image. There it is, as a TIFF file. The recentered average image, and there it is, and I can zoom in on this one nicely, and you can kind of see the laser spot. After recentering it, did a good job of keeping it in a nice small spot. And then you have CSV files for the power in a bucket, the second moment, the first moment, all here in the results file. A couple more features I want to mention. One is the movie mode. So you can click on movie and specify a location. I'm going to put it on the desktop. I'm just going to call it test. Terrible idea to do that. You end up with a ton of movies called test. And then if I then look on my desktop and double click on it, Windows doesn't actually play it very well. I usually use VLC to play these. So let me open this up with VLC Media Player. And there is a movie of the spot moving around as an AVI file. See if I can get that to overlay with the screen a little bit better so you can see that. And so it is playing through this movie very rapidly, of course, and you can see the spot moving around there. Okay, so that is the AVI of the movie of the DAT file generated from the DATViewer. Finally, there's this concept in here called bulk processing. If you open this up and select multiple DAT files, it will go through and run the analysis on all of them. And it will save this out into a variety of formats. And it will do that for each one of them, processing them all the same way. In this case, the spot was in a different location. And this one had 100 frames, and the spot is about there on the screen. So this is going to take a few seconds for it to get through, but you can see it's almost done. There we go. So it went through and analyzed all those and saved out those results for us. And now it's analyzing the last file. Okay, and it took an elapsed time of about 51.9 milliseconds. I'm sorry, 59.1 seconds to do all those files. So this allows you to process a whole bunch of files. Finally, if you have found an image that you particularly like, you can save that image out directly. And in this case, I can just put it on the desktop, and it will save that image out as an image file format. And I can open that up here and again, zoom in on that individual image. And there it is. Okay, so this was a quick tutorial on how to use the DATViewer and how to analyze images, create movies, save individual frames, and take a look at this with and without various color bars. And so hopefully this will help you analyze your DAT files that can be recorded out of the AOS viewer. If you have any questions, please don't hesitate to reach out. Again, this is Justin Mansell from Active Optical Systems. Thank you.